Welcome everyone to NASA's Foilsim software, Foilsim 3. We'll be using this software for Activity 4.2.3, Airfoils, Lift, and Bernoulli's Principle. I have my lab open to the bottom of page 3. There are directions, step-by-step directions, to tell you what to do for this lab and this software. Those directions were written for a previous version of Foilsim, and the program has recently changed. So, I have created this tutorial to show you what to do step by step. The first thing you want to do is you always want to reset the software to make sure it's back to its natural state. Okay? I want to talk about some of the parts of this software. The first thing we have is we have our output screen over here. Okay? This is an airfoil. And we can see that there is wind around this airfoil. The wind is being curved over the top of this airfoil and underneath it. We also have some ways to change our airfoil. We can change its angle of attack, we can change its camber or the hump of the airfoil, and we can also change its thickness as well. Over on the right side here, we have inputs and we have outputs. We can change the flight itself. We can change the flight, its speed, its altitude. We can change the size of the wing itself, the shape of the wing, which I showed you previously. We can also do some analysis on this wing. And we can also change our outputs. We can plot this as a graph. We can use probes. We can use a velocity probe to measure speed. We can use a pressure probe to measure pressure. And a smoke probe to see the trail that the wing is leaving. Okay. There are also other gauges. You can look at geometry. These are coordinates and other data. Okay, so there's lots of data here that we can check out. So going back to that, the last thing I want to show you is an output here for lift. Right now, this airfoil is producing 1,490 pounds of lift and 131 pounds of drag. You want to make sure that your airfoil is creating more lift than it is drag, because if it's not, will this plane fly? No, it won't. I'm going to reset the program, and I'm going to work through the first portion of this lab. If we were to read those step-by directions, I'm going to go through it with you. It's much easier. The first thing we want to do is we want to select probe. Okay? We'll be using the velocity probe first. Secondly, in the lab, it's asking us to change the angle of attack for this airfoil from 5 degrees to 0 degrees. So I'm just going to highlight this, and I'm going to hit 0. Now notice, the angle of attack for this foil did not change yet. To commit to the change, we must hit the enter button. Now our airfoil is at 0 degrees. In the directions, it's telling us to move our probe from behind the airfoil to the thickest part of the airfoil below the airfoil itself on the first wind line. So I'm going to use the horizontal controls here to move the probe. Now it's above the wing, so let's move it below using the vertical positioner. This takes a few seconds. I'm on the first wind line, and I'm under the thickest portion of the airfoil. It's giving us a velocity of 1.152 times 10 to the second power, miles per hour. That is the speed of the wind traveling underneath this wing airfoil. Next, it's asking us to write down the pressure. So all I have to do is select the pressure gauge. And now we have a pressure of 1.464 times 10 to the first power, PSI. PSI is a unit of pressure standing for pounds per square inch. Next, we need to measure the pressure and velocity above the wing. We do not need to touch the horizontal controls. All we need to do is move the vertical control above the wing. All right, we are on the first wind line above the airfoil. It's giving us a pressure of 1.464 times 10 to the first psi and a velocity of 1.141 times 10 to the second power miles per hour. These are the data points that you will want to put into your lab. Looking at this airfoil, does this airfoil produce any lift? No, it does not. Why does this airfoil not produce any lift? These questions will need to be answered by you and your partner. Any questions, comments, or concerns, please raise your hand. And to watch, make sure you watch other videos in this series.